Today we're going to have a look at data visualization. Data visualization is a way of representing information in an artistic way, in an interesting way. Scientists might be happy with scatter plots and black and white boring graphs, but if you want to communicate information and data to the public, you want it to be fun, you want it to be enjoyable, you want it to be colourful. And we thought we might have a look at a particular guy's work called Martin Kavinsky. Today we're actually going to look at some of his more numbery but artistic work. So we're going to have a look at him finding beauty, so we say artistry, in the randomness of pi. So we've got it down here. This is pi in a beautiful, colourful way. Now this is, first of all, the most simple way I think that you could have done this. All he's done is taken the digits of pi and he's given each digit a different colour. So it starts with 3, so it looks like 3 is an orange colour there. 1 is a red, 4 is a yellow, 1 again is red, and then 5 is green, and I think that's a 9, that's purple. It's made this really beautiful poster. You can kind of see the randomness of it though. I don't see there's any particular pattern to the colours, which reflects the randomness of the digits of pi as well. He took that a step further and he started to colour the centre of the circles using the colour of the next digit. I think he only did that just to make it a little bit prettier. But I think he found it interesting because he started to join up digits that had the same colours in them, which looks like this. There we go. Can you see that? So he's connected digits or adjacent digits in his poster that have the same colour, so they'll be the same number. And he kind of makes these disconnected networks. I don't think there's any great mathematical truth to find underneath this. This is for art, and Martin's very clear about this himself. This is less about the mathematics and more about the beauty of it. But it is intriguing as well. The other way you could do this is if you put the digits of pi in a spiral like this. This kind of reminds me of the tiling in a Roman bathhouse, something like that. Maybe that's the colours he's used. But to take this a step further, and this, I think, is one of our favourites.
Oh, yeah.
I think this is one of Brady's favourites, isn't it?
Yes.
I think we should just appreciate the beauty of that for a moment before we describe it, before we ruin, really, the beauty of it by describing it. We should just appreciate that. Now, what he's done there, he's connected the digits together as you go through the digits of pi. So he started at 3. And then he's connected 3 to 1. So it'll go here. Then he's connected 1 to 4. So it will go down here. Then he's connected 4 to 1, so it goes back to 1. Then it will go to 5, and that will go to 9. And he's connected them in that way. And he's also given each digit a colour as well. So it's like a path. He's made a path. He's put the numbers in a circle, 0, 1, 2, 3, 4, 5, up to 9, and you've made a path. And it makes this beautiful circular piece of art. Data visualization is hugely important. It goes way back. And when we talk about Florence Nightingale, she had to represent her statistics that she had in the Crimean War when she was a nurse, and the deaths that she was suffering on the wards. It was because they weren't clean enough, and she would represent this data. She was a mathematician herself. Florence Nightingale, fantastic. And she had these things called rose diagrams, which I actually think are hideous, but they are a similar idea. They're representing data in a visual way. I mean, a more simple example of that is a pie graph, representing data in a visual way. And what these guys now, and I think it's become quite a thing recently, is to make it beautiful as well. And that's important because to communicate, especially to the general public, you want to be able to look at this information, understand it, and enjoy looking at it, and you'll appreciate it better. We can talk about serious mathematics, subjects like combinatorics, which is very visual as well. And you can then do maths through pictures and diagrams and things like this, networks and graphs theory and things like that. In this example that we've got here, there is actually something we can look at. So we think that pi is pretty random. Martin actually compared pi here with a few randomly generated numbers. So he generated, these aren't pi, these are randomly generated numbers. He did the same sort of artistry. And you can see the similar sorts of patterns coming through. The pi has the appearance of a randomly generated number. Another piece of art by Martin is the same idea again, our circular paths, but here he's put little dots on the outside just to show you where the lines are coming from and where they're going to. So if it's 3.141, then above the 3, he's shown with a little dot that it's going to the number 1. And then above the 1, it shows that it's come from the number 3. It's just shown where it's going to and where it's coming from. So the size of the dots means that this occurs more often. Actually, look at this one. There's a big purple dot. And this shows that it's actually purple, it means 9. And it's above the 9 here. What it's showing is there's a sequence in pi that is just 9, 9, 9, 9. It's the Feynman point, which I know Brady is a big fan of, which is 6 consecutive 9s, somewhere around the 760-something digit. I think it's 762 digit in pi. And you can see it. That is there. Those are 6 consecutive 9s, and it makes a big blob because it's coming from 9 repeatedly. Martin has done this for other numbers as well. He's done it for the golden ratio, another famous mathematical number. He's done this for E, another famous mathematical number. And what he was interested in, though, when he started doing that, was where they coincide. What he did is he lined up these 3 special mathematical numbers. He lined them up, and he wanted to look at where they had the same digit. Now, because these numbers are kind of random, really, when they have the same digits, that's just random. So for all 3 numbers to have the same digit, that happens with a probability of 1 in 100. But when he lines them up, he got something he called the accidental similarity number. And he discovered that, yes, they do line up with the same digit about 1 in 100, which is what probability tells us. So they have a sort of an average gap between lining up of about 100. And he started to experiment with his accidental similarity number. He made some pieces of art based on that as well. There you go. Here's another piece. Here's another one of our circular ones here. And doesn't it look pretty? You should go to his website as well, where he'll explain more details about how all these things were made.
Can you do that again and this time talk me through it as you do it?
You ask a lot, Brady.